Okay, so for this CFU, I'm just going to go through how I would personally answer each of these, just to give you a kind of, method for each of these if you got any of them wrong. So in question one, you're asked to do A and D. So for A, I'm looking for, so I'll just copy this out. What we wanted to do is look for numbers that multiply to be this last number. So just over here, I'm looking for numbers that multiply to be negative 15, but add to be the central number. And they're the ones that will go in my brackets. So I'm just thinking here, what could that be? And I'm thinking minus 5 and 3. Minus 5 plus 3 is negative 2. So these are the numbers I'm going to put in my brackets. So I've got x minus 5 and x plus 3. So that minus 5 comes from here, minus 5, and the positive 3 just next to it. If you did have a non-singular coefficient of x squared, there are a few longer bits to do for this. But for now, whatever you get in this part, you can put straight into the brackets. You're not asked to, you are asked to solve these, so it's not just to factorize. So it's x equals 5 or x is minus 3. And again, these are coming from, just kind of incorrectly done that. These are coming from the fact that if you've got two numbers multiplied together to make 0, one of them must be 0. So in actual fact, a line missing here is the fact that we've got x minus 5 equals 0, or x plus 3 is 0. So one of these statements is true. When this one's true, we know it's x is 5, and when this one's true, we know it's x is minus 3. So it's remembering that this line actually exists up here, and that's what you're actually solving there. For D, same idea, you just want to, but first of all, remember to solve or factorize a quadratic, you want it equal to 0. So we're going to take all of these across the left-hand side. I've got x squared minus 5x minus 3x is going to be minus 8x. And I've got positive 18, subtract 2, so that's a positive 16. So this one I'm looking for numbers that times to be a positive 16, but add to be a negative 8. For this one, there's only one option, which is minus 4 and minus 4. So again, in here, I'm going to put x minus 4. And because it's the same number, I know I can actually write this as x minus 4 squared. You can write it as x minus 4 times x minus 4. I'm just having a little bit of foresight here, and I know I can write as x minus 4 all squared. And again, when solving this, I know that bracket must be equal to 0, so that can only happen when x is 4. So question 2. Again, just another variant in solving. A big thing that I would always recommend here is once it's in this form, don't try trying to expand it out and get it back to equal 0 so you can use the formula. Solve it straight from here. This is a beautiful kind of way to solve these. Reminds me of completing the square, and then you're just rearranging this. So if I have 2x minus 3, that's then being squared, and it gave me the answer of 25. So it is this square that you want to unwind first. So opposite square is square root. So I get 2x minus 3. Is equal to, now the square root of 25 gives me a positive or a negative 5. So just remember, when you're given that square root, you've got to have that plus or that minus. Then the next one, I want to get rid of the plus 3, so I'm going to add 3. So I'm just going to put in brackets what I've done here. So I square rooted. On this step, I'm going to add 3. So I get 2x is 3 plus minus 5. I like to put the number, the constant I've just added in front of the plus minus, just because it looks a little bit nicer. And then this one, I just want a singular x, so I know I need to divide by 2. So I get 3 plus minus 5 divided by 2. Now, of course, it's a quadratic, so this is going to give me 2 answers. So when I do the plus, I get 3 plus 5 is 8, divided by 2 is 4. And on this one, with the minus, 3 minus 5 is minus 2, divided by 2 is minus 1. So it's just remembering to answer the question properly there. If it was a third, I'd have left it, but because it does come out nicely, I'm looking to simplify where I can. I'm not going to talk through this too much, same kind of method here, so I'm just going to actually do it line by line. Start by writing out the question now. So don't forget that plus minus. I like to put the constant in front of the plus minus, and then that's my final answer. I don't want to write them as decimals here because surds are a lot more accurate. If it did want me to carry on and do things with this, I might put them in decimal form, but the surds are much more accurate here. So that's question 2. Question 3 is to use the formula to solve. So first thing is, I'm supposed to write down that formula. So x is the negative of b plus minus the square root of b squared minus 4ac. And this part tells us a lot, which we'll find out later, divided by 2 times a. So I would always recommend to rewrite out your question, make sure it's of the form ax squared plus bx plus c equals 0. So make sure it's equal to 0. Then underneath, just write down what a is. So a is the coefficient of x squared, it's 3. B is the coefficient of x, which is minus 7. And c is the constant, which is negative 1. Make sure you write those down and then simply substitute them in. So I've got x equals the negative of b, so a negative of minus 7. I'm not going to put that in yet. I'm simply just going to put b in there. So it's minus b plus minus the square root. Again, I've got b squared minus 4 times a times c. So I like to just put them all in with brackets. And underneath, 2 lots of a, which is 3. And then I'll tidy it up. So I'm not doing too much in my head all at once, just bit by bit. The minus 7 is 7. Plus minus, the square root. And here I've got minus 7 all squared, so 49. And then here I'm noticing that I've got a minus times a minus 1. So it's actually going to become a positive here. And then 4 times 3 is 12. And then on the bottom, 2 times 3 is 6. So all I'm doing now is looking to tidy that up. Just run out of space. So I'll just come over here. So x is 7 plus minus. Then 49 plus 12 is 61. So I've just got that square root of 61 divided by 6. Now at this point, I'd be looking to see if this surd simplifies, and also if 7 and 6 have anything in common with each other. It doesn't, so I'm just going to leave it in that form. Now again, to check to see if that surd simplifies, you need to find any square numbers that go into it. So I'd be looking at 1, well, I wouldn't look at 1, not at all. I'd be looking at square numbers greater than 1, so 4, 9, 16, 25, or 49. None of these divide into there, so there's nothing I can do. So that's my final answer. Function f, so let me just have a quick read of this one. Okay, so function notation here, so we've got a function of x, so x is put into this function, and this is what's happening. This last little bit, don't be too freaked out by that. That just means x is a real number. And for us, real number is all numbers we actually know at this stage. It could be positive, it could be negative, it can be 0, it can be decimal. So it's all real numbers. So basically x is any number you can think of. It's basically saying that there's no restrictions in this formula. We want to rewrite it in this form. I'm hoping you recognize that this is a complete in the square form. So I'll just stick that there. So we want to complete the square. So I'm going to start with f of x is x squared plus 6x minus 5. And I want to rewrite it in this form. So I'm actually going to just write what's here. And we've got x plus something all squared. And then in actual fact, we end up taking away something. And then we've got to minus 5. But I'm going to start at this stage. So for completing the square, we look at the first 2 little bits. So as long as it's a singular x squared, there's no factorizing. We halve the b term into here, and then we subtract whatever that is squared. So what this is doing is it's manipulating these 2 first terms into a kind of a user-friendly form, I suppose, where we get rid of this x squared and this x, and we're left with just a singular x in a bracket. So that's just these two. If we were to expand this, x plus 3 squared minus 3 squared, if we expand that, we get x squared plus 6x plus 9, and then this minus 3 squared gets rid of that 9. So we actually end up with x squared plus 6x, which is what we started with. And then lastly, don't forget this minus 5. And we've just got to tidy that up. So the x plus 3 is squared. This is minus 9 minus 5, so that's going to be minus 14. And that's the completed the square form. P is therefore 3, and Q is minus 14. It then goes on to say hence or otherwise. So when a question says this, it means it effectively says use what you've just done to find the roots. It does give you the option of or otherwise. So if you don't realize what to do here, you could in theory go back to the original and factorize it, or try and complete the square, or well, we've just done that, or use the formula. The fact it's saying leave your answers in third form is telling me, well, we're probably not going to be able to solve this into a factorized form nicely. So what do we do when finding roots? Well, we set that equation equal to 0. So the roots are when f of x is actually 0. So we've got x plus 3 all squared minus 14 equals 0. Rearranging this, sorry, this is part B, this is part A. Rearranging this, we get x plus 3 squared is equal to 14, and this is just like the last question now. So I'm gonna just skip through a few little bits here. I've got x plus 3 is plus minus root 14. So x is minus 3 plus minus the root of 14. So that's my final answer for that. So there's the roots. Now it's saying write down the minimum value of f of x and state the value for which it actually occurs. So it's not asking us for the turning point itself, isn't C? It's saying the minimum value of x. Now you can get this turning point from the completed the square formula. So remember, completing the square formula, whatever makes this bracket 0, that's the x value. So that's minus 3. And then this endpoint is the smallest value it can be, or the minimum value. So that's minus 14. So this is the turning point. What that actually means is that at x equals minus 3, the lowest value of the y can ever be is minus 14. So this bit here, this is the minimum value of the function. That's what it's asking for. This bit is the x value for which it occurs. I'll just paraphrase. So in order to answer our question, the minimum value of f of x is actually minus 14. And this occurs when x is minus 3. So it's actually this bit and this bit that I need. I won't see a sentence there really. It is just relating to the turning point, but it's saying, do you understand what that's telling you? A quick insight to that, just so you understand how that works. The smallest value a square number can ever take. So if we look at, I can't change color really easily here. If we look at our function f of x is x plus 3 squared minus 14, the smallest value this can ever be is 0, because the smallest number, so if you start with 0 squared, it's nothing. Any other number gives you a number bigger than 0. So if it's negative, it becomes positive. So like minus 1 squared is actually 1. That's bigger than 0. 1 squared is 1. That's bigger than 0. So the smallest number this can ever be is 0. And that occurs, how do I make this 0? Well, the x must be minus 3. Minus 3 plus 3 is nothing. So that's why this first one is minus 3. So that's why your x coordinate minus 3. When that is 0, what is our function's overall value? Well, we've got nothing, take away 14. So our value of x, our value of the function, sorry, when x is minus 3, is minus 14. And that's where the minimum value comes in. It's a minimum because its equation was a positive x squared, so it had that kind of shape to it. So our minimum value is looking somewhere like here, where this is minus 3, and this is minus 14, so that's a terrible kind of graph for this. Let's try and draw it properly. So we know it comes down it goes back up and it looks something like that. So this point here, this occurs when this is -3 and where this is -14. So again, that's a quick sketch for that. This value here would be -5, and hopefully you understand where I'm getting these points from now. But there's that going on for you. And last one, sketching graphs and finding turning points. So a few different ways of doing this. Personally, for me, I'd complete the square and solve it that way. There are multiple ways of doing this. So I'm gonna do it twice and then I'll sketch underneath. So in order to do this one, firstly, you might look to factorize this. So you might be saying, actually, x squared minus 5x plus 4, it could look like, oh, let's actually write this, x minus 4 and x minus 1. So to find the roots, we set equal to 0. So x is 4 and x is 1. That will tell me the roots of this equation. So now to sketch this, I know 4 and 1, so 1's here, 4's over here. I also know from the original graph, it goes through 4 as the y-intercept. So it crosses up here at 4. So it's going to come down, go through that 1, and then back up through that 4. And because I've bodged that, I'm just going to update these and pretend like it was fine all along. So this is where I put my 1, and this is where my 4 was. Perfect. All I need to do now is find that minimum point. And in order to do that, there's a few different ways, but you can find the midpoint of these two values. So 4 and 1 have a midpoint at 2.5 or 5 over 2. So 4 plus 1 is 5, divided by 2 gets me this point. That's the central line. So every quadratic symmetrical, that's that central axis. To find the value on the y, I need to know what's the value of my function when x is 5 over 2. So I'd literally just put that into my original function. So I'm going to do it this way, but f of 5 over 2 is equal to 5 over 2 squared minus 5 lots of 5 over 2 plus 4. And I've just got to work that out. Now, I'm going to do it manually. Most of you will probably use your calculator. So 25 over 4 minus, this is going to be 25 over 2. So that's actually 50 over 4. And because these are all over 4, I'm going to make this over 4 as well. So that's 16 over 4. So I'm just doing this mentally rather than using a calculator. 25 minus 50 is minus 25. And minus 25 plus 16 is minus 9. So this is going to give me minus 9 over 4, which is this value here. Phew. So that's the first way. That's not involving completing the square. It's quite a nice method. The other method is to complete the square. So we put x, we half this. That's going to be minus 5 over 2 squared. We take away whatever that is squared. So minus 5 over 2 all squared. And then we've got that plus 4 coming in as well. So that's what y actually is. We tidy that up a little bit. So I'm just rushing through this now. But this is going to be what's that? Minus 25 over 4 plus this 4, which in total is going to be minus 9 over 4. So this tells me my minimum point. So the minimum will be when 5 over 2 and minus 9 over 4. So that's the minimum point. It comes straight from this. The roots, however, so I can't sketch this yet. I need to find the roots. The roots I'm going to have to solve when this is 0. So in order to find the roots, I need to let y equal 0 and then solve this. So I've got x minus 5 over 2 squared minus 9 over 4 equals 0. The first thing I'm going to do is move this across here. So in actual fact, I'm going to be a bit lazy. I'm just going to update it there. So it's like that. I'm going to square root both sides. So I get x minus 5 over 2. Don't need the bracket there. Is equal to the square root of 9, which is 3, over the square root of 4, which is 2. But I did square root, so don't forget that plus minus as well. And finally, I need to add. So x is 5 over 2 plus minus 3 over 2. So if we work those out, 5 over 2 plus 3 over 2, so 5, 6, 7, 8, 8 divided by 2 is 4. Or, what we take away, 5 minus 3 is 2, 2 divided by 2 is 1, so x is 1. They're exactly the same as what I got originally. That now allows me to draw most of my sketch. Don't forget, you should also always set x equals 0 in the initial one to get the y-intercept. So when x is 0, y equals 4. I did that in the last one. That tells me my y-intercept is 4. Got my x is 1, it's also 4, and I know the minimum occurs down here. So again, you're just sketching that as best you can. You need to do yours carefully. Using this tablet is a little bit trickier. So this point here is 5 over 2, and on the y, it's minus 9 over 4, but just making sure it's all clear. So mine's a very bad sketch here. If you're doing it in pencil, it should look a lot nicer, but making that clear. Some people do actually like to label this point, so you put in brackets here instead, just to make it really clear. I quite like doing that as well. You know, it's both ways work, and they both give you that sketch. That's just my way of doing this. Everyone seems to have their own different ways. I've shown you a couple of ways for some of them. Hopefully that helps.